Hi guys, welcome back to my channel. This is Engineer's Guide. Today we are in the fire pump room and I'm going to take you through this fire pump room. Actually, this fire pump, this is the diesel engine controller. It's TORNATECH, but it's the old version of it. And this is the jockey, the one with the dip switches. Okay, this also is with the dip switch also as well. We will just check the overview of it. This is the electric fire pump controller. Okay, and as you can see here, this is our battery. This is the diesel engine from Clark. It's from Clark. All right. Okay. And this is the diesel tank with nothing here. Usually we used to put sand here, but as per recommendations, it has been said to remove all the sand. In the case of the sand, when the diesel drops in and it catches fire, it can hold fire for a long time. So if it's dried with a plate down, metal plate down, you could just remove and clean it up. It's easy to clean. Okay, and here we have the electric, the jockey pump, and this is the electric fire pump. Okay, this is the network. This is the water tank. The capacity, total capacity is 223 meter cube. That is. And the effective tank capacity is 179. This is the fire water tank. Now, as you can see from here, this is the suction. This is the suction with one tank here and the other is here. And this is the one that circulates the water together. Okay, so let's go through. From here, it's directed here to an elbow, then to a strainer. It's really important to strain the water before it will come to the suction. Okay, and this is the OS and Y valve. To here you come to the eccentric reducer, then to the pump itself. This actually is a centrifugal fire pump end suction type. This is the end suction type. Okay, we have the horizontal split case and the end suction and the rest that we have. So from here you can see that there is a concentric that has been placed in here. It's a reducer. It's reducing to up to the, so we will not term it because now it's expanding up, so we say it's an expander. It's expanding up. Okay, up to the suction, the NRV. This is the NRV actually. Then we have the butterfly valve. Okay, so this is the butterfly valve, and you can see that this pipe here is connected to the side of the 6-inch check valve. Okay, down to the panel of the electric. All right, then you can see from here also as well, going to the next pump, that is the diesel pump. And from here, this is the jockey with its valve. Then here, directly to the pump. So on the jockey also as well, you could see from here straight up, this is the check valve. Then there is another valve, then that's the sensing line. All right, so as you can see here, most people, you see this, it has been written on as DN150 and it's denoted as 6 inches. 6 inches. So sometimes when you don't see DN150, you could see 6 inch. or you don't see 6 inch, you could see DN150. That's the diameter of it. Okay, so then how would you know that DN150 is 6 inch? Easily, I will just show you. So as you can see from here, on this meter, you could see that 6 inches is equal to what? 15 centimeters. But the DN150 is calculated in millimeters. Okay, so the 6 inches can be equal to 150 millimeters. So you could see 150 millimeters or 6 inches. So then, what if the pipe is 4 inch? So then you could see that it will be DN100. So you could check your calculations and do the mathematics for the rest of it. What of 8 inches? It's 200. All right. So it's as easy as that. So then it will just take us to when we are being told to calculate for this. This is the test line. So with the test line, we will have the bypass line and bypass valve, and we are going to have the throttle valve. So the bypass valve is the one that the water is going to bypass. We will open, then we will use the throttle valve to just check the flow. So now this pump is 500 GPM. So what you can see here is double. It's 1000 GPM flow meter. Okay, 1000 GPM flow meter. So then when we want to check, mostly we check the 0%, we check the 100%, then we check 150. So the 0% is going to be on the 0, the 100% is going to be on the 500, and 750 is going to be the 150%. Okay, so when you do the mathematics, 500 divided by 2 is 250. 250 plus the 500 is 750. As easy as that. Or 1.5, you multiply it by 500 and you're going to get your answer. So then, usually we are told that in calculating in the piping of testing line, it has to be 5D and 2D. These are the requirements that is always being asked of. For you to get an effective flow, you need to just follow the instructions of 5D and 2D. And I would want to know the reason why that we do that. So you could just comment below the comment section, then we know what is it. And actually also it is being said that on the split case, horizontal split case, the suction is also supposed to be in 10D. So I would want also people to just comment on what is the 10D and why do we have to go by the 10D? What is the effect on the water, and what is the importance of following the 5D, 10D and 2D? So now, as we are here, we will just check now. So let's hold on. So then if we say 5D, from the bypass valve to the flow meter, it's supposed to be 5D. So it's going to be 5 times the diameter. So the diameter is 6 inches. Okay. So if it's 6 inches, 5 times 6 is going to be 30 inches. Or we can use the DN150. That is the diameter. So then the diameter is going to be 6, the 5 times the 150. Okay. So the mathematicians, what is the answer? 515 plus 2 is 7. Okay. So then we are, it's going to be 750. Okay. So, but by calculation, if we would check the 5 times the diameter, that is of 150, you're gonna get, let's try, oh, I'm sorry, I cannot get the thing up there. I'm along. Okay. So it's over. So okay, I will just check and tell you. Wait, this is like 80 centimeters. Okay, so then it is more than the 750. So it's okay. All right, it's more than the 750. It has to follow that rule, 5D. And I think for this we can get it clearly. So from here to here, we are getting like 37 centimeters. Okay, 37 centimeters. So if we are having 37 centimeters, let's do the calculation. So then this is 2 times 6. It's going to be 12. Okay, so what is 12? 12 is 1 foot. Okay, so 1 foot is like 30 centimeters. So it's a little bit more than that, which is okay. It's better to be a little bit more than to be less. So then we can stay in the requirement. Okay, so this is directly going into the tank, fire water tank. So during testing time, this is what. And here we have the air release valve, which helps in the removal and in the separation of air and water. Okay, so then whatever air that is being trapped in the system is going to be removed through that, right? You could see that before the check valve here we have relief valve that relieves the system in case there is high pressure. Okay, so the relief valve can be set to the required pressure, and when there is the need, it will automatically relieve it. All right, so this is the diesel engine. You can see from here, this is the diesel engine from Clark. All right, and in some of the videos we have the testing of it, so you could see the network of this. It's so nice. Okay, this is the main discharge valve, and the alarm check valve is over here. All right, the alarm check valve, and these are the sensor lines that are being lined up directly. One is coming, this one is coming to the diesel, that one of the jockey, and that one of the electric. All right, so you could see the arrangement of the fire pump room. It's so nice, it's okay, and it's spacious. So from this angle, you could see how the arrangements are. It's so spacious, and that is how mostly the fire pump rooms are supposed to be like. Most of the pump rooms you go, you cannot even have foot to just step. You will just be stepping on the cable trays and just moving in, even standing on the pipes and a whole lot. But it's supposed to be ventilated, and it's supposed to have clarity, so you can see the lighting system and everything here is clear to be seen. And the nameplate of the cutting and the cutouts also has to be pasted. It also has to be pasted. All right, these are the modules that are being used here. All right, there is ventilation, there is AC and emergency lights. So it's good, it's quite good, and the flow has been checked. The flow is okay. So in the next video we're going to test the fire pumps, then we're going to know how it works. But for those that are first timers here, before this pump will start, it starts from the jockey pump. The jockey pump has an automatic start and stop. This is how it has been set. Okay, and this is the requirement. You could just make it manual stop also as well, but the requirement says that the jockey has to be a booster pump, which will just be enabling pressure. So from here you could see the jockey has cut-in of 130 and cut-out of 145. So when the pressure drops up to 130, it's going to run by itself, and it's going to cut out at 145. Then you could see that from 130 here the pressure has been set to 115. All right, so then if it drops beyond 130 and comes to 115, the electric is also going to run. The cutout is 145, but mostly it has been set to manual stop. Okay, the cutout is just universal, that it has been put like that. All right, so then you could see from here that the diesel is also, the cut-in is 100 psi and the cutout is 145. Same thing also, when the electric is not able to just pressurize or meet the required pressure that is in the system in case of usage, the diesel is going to start when the pressure drops up to 100 psi. All right, so that's how the system works. And with this, it has to be stopped manually, both diesel and electric. But in settings, we could just make also automatic also as well. But as per the requirement, it's supposed to be in manual mode. Okay, so this is the diesel line directly from the wall to the tank to the diesel engine, then so on and so forth. So let me hear you from the comment section, whatever that your views are, whatever that you think that we should touch on, you could just ask us and we are going to do justice to it. All right, thank you. Please like and subscribe for more videos. Thank you.